Everyone, uh, welcome to Savi channel. I'm a course instructor Pawan Kumar along with Chaya and Prabhake and Manjanachari. Today I will be going to explain you interface of DC motor with LPC1768, which is the VTU curriculum syllabus interfacing program. So maybe you have executed a lot of programs in the previous lab sessions. This is one of the experiment which is interface with a 1768 series. So as you know, what is the difference between different motors, like AC motors you have, DC motors you have, servo motors you have, stepper motors you have. But in your experiment you have a DC motor interfacing. What is DC here means direct current motors. Basically here we go give the DC current or DC power as a source, which may be starts with 3 volts, um, 5 volts or 12 volts. So likewise in the experiment you are going to connect your DC motor directly to the LPC 7868 or 1768 board. So coming to the working of motor, basically it's an electronic motor. Means basically what happens, it's like in single way we call it as actuator. What is actuator means giving a electrical pulses converting into mechanical actions. So in this category the DC motor comes into the picture. Okay, so DC motor is also called as a actuator. An electric motor which is electrically driven by the this motor, and the basic working principle is where current carrying conductor is placed in a magnetic field, it experiences mechanical forces. So DC motor were the first type widely used since they have powered with exciting direct current, lightning power distribution system. DC motor can work in a clockwise or it may be anti-clockwise. Based on your application you can work it. There are like examples or applications of DC motors can be used in small tools or toys and other appliances. And basically what happens, brushless or brushed um, motors will be available. So this is about a little bit introduction or a working principle. So coming to the before going for the structural or working of the DC motor, we have to know what is L293D. As we know that DC motors are a high current rating, which we cannot directly connect it to the LPC or any of the ARM processor or a microcontroller. To compensate this operation, we are going to have, or we are going to use a one more IC called L293D. So L293D is a driver IC. Basically it's a mediator between a microcontroller and your DC motor. So here you can see LPC L293D is a typical motor driver which allows the DC motor to drive either in direction. So any one of the direction it can be configured. And L293D is a 16-pin IC. So here in the figure you can see it start with a 1 and ends with a 16 here. 1 it will be enable 1 and 2. Pin number 2 is a input. Pin number 3 is a output 1. 4 and 5 are the grounds, and 6 is the output 2. 7 is a input 2, and 8 is a VCC 2. Okay, so here what is that means, for your output 1 and output 2 you are going to connect your motor. For input 1 and input 2, these are all orange color. You can see here that these two pins are connected to the uh, microcontroller with respect to VCC. Same wise, here also it is being configured. So at a time, L293D can drive two DC motors, and this is also called as a dual H bridge motor. Keep in mind, it is also called as a dual H bridge motor, where it's like allows the voltage to be flow in either direction. It's like in the both the direction. And what are the few of the few features of L293D is like it can be have a like two DC motor be connected. You can run in either of the direction or in same direction. Second, speed and direction can be controlled very easily. The motor voltage starts with a 4.5 motor voltage VCC to 4.5 volts to 36 volts, maximum current of 1.2 amps we can, and maximum continuous currents of 600 milliamps, and power supplies of the whole like VCC1 can work with a 4.5 volts to 7 volts. Like your transition times starts with 300 nanoseconds. So it can be available in the deep form. It's like a IC package, we call it as in single way. So this is about the L293D. So in the next slide, you can see here like how L293D is connected with a DC motor. So your 16 pin is connected to the 5 volts, and your 8th pin is connected to 7 volts, and your 13 pin and 12 pin is both are shorted, and 4 and 5 are also shorted, and it's given for the ground. And here you can see the configuration of motor connection. Input 1 and input 2 are connected to the controller, that is nothing but LPC1768, and pin number 3 and pin number 6 are connected to the DC motor. Okay, so this is how we are going to connect DC motor for the microcontroller, any of the microcontroller, but in your lab session you are going to connect it to LPC 1768. Okay, so next slide is very important. Here what happens, like once you got configuration everything, how you are going to connect it to your motherboard as you are using in the lab. So some of the key IC numbers, IC pins we have to keep in mind before connecting to the LPC 1768. The first point says like input 1, pin number 2 of L293D is connected to the port 4. Okay, so here you have to remember that these numbers are very helpful for the uh, connection of DC motors. So port 4.28, it is a input 1. So the next point is input 2, here is connected to port 4.29 GPIO. So as you know, in the previous experiments you could done lot of interfacing, but here like we should know input 1 or input 2, port 4.28 and 4.29. On the enable pin also we are supposed to connect it to port 2.8 GPIO. So this table shows that like configuration of DC motor and how you can run the DC motor. So few things we have to remember here. uh, to run the motor in a clockwise or a counterclockwise, or you have to stop, or you have to make it DC motor in an ideal state. Few of the things we have to remember. Here motor 1, like DC motor CW clockwise, P 4.28 1 4.290. So you want to run your DC motor in a clockwise direction. We are supposed to send a data to this particular GPIO as a 1 and 0. So counterclockwise, you want to run your DC motor means we are supposed to send the data in the form of pattern like 0 1. So once again I'll repeat here: DC motor clockwise direction 1 0, DC motor counterclockwise direction, that is nothing but in a reverse direction 0 1, and you want to stop your motor. DC motor means both of the pins we are supposed to send 1 1, and ideal state means 0 0. So every time the DC motor has to be run clockwise or anti-clockwise direction, the L293D has to be enabled. So here, as in the this point I have explained what is which pin is being connected to enable pin. So in the table you have to note down that P2.8 is equal to 1. So if you remember this pattern, it is very easy to write your program. Okay, so this is about the configuration. So let's see next slide about regarding the GPIO and how you are going to activate. So here this is very important. Like already we have explained the previous experiment how your 32 pins 32 pins of GPIO, each slot is been further divided. So here GPIO port is used, as we saw in the previous slides, like port 4 and port 2 are used. So what is the configuration of port 4 for the 4.28 and 4.29? So here you can see your port start from 0 to 31 here, as we know that it's a 32-bit wide. Suppose, as I told, 1 1 you want to send. 1 1 means like a, the first bit is 1 and second bit is 2, totally 3, right? So here you can see the pattern like 3 0 0 0 0 is as like it is like 32-bit wide. So it is going to stop your motor. uh, like clockwise direction you are supposed to send 1 0. So what is the pattern here? The first bit is 0 and second bit is 1, that is nothing but 2. So 2 0 0 0 0, the motor rotates in a clockwise direction, and anti-clockwise direction or counter-clockwise direction 0 1 you are supposed to send. The first bit is high and rest of the bit is 0. So that's why the data will be 1 0 0 0. The motor rotates in a counterclockwise direction. So here you can see the example, like which two bits like 29 and 28 bit will be activated based on this pattern of a data. Okay, 1 1 1 0 0 1 0 0. Okay, basically we won't send any 0 0 for that, but we have to keep in mind these three are the patterns, and these three are the datas which you are going to write a code. Okay, and same ways as I told, like the last bit pattern is here for port 2. As I told, port 2 is used for enable pin. So, and that also it is I showed you in the previous, like 2.8. So here you can see that the 8 bit is 1. Okay, so it's been written in the words also. How you are going to send, like a 0 0 0 0 0 1 0. So this is these slides, first one, the second one are very important. If you remember these two patterns or these two slides, it's very easy to write a program. I hope you have understood the slides. So here it's last comes to the program. Let's see how you can write a program, and you know the procedure how to dump the program into the kit. Later, that is a practical session, you can do it. But here let's see how you can write a program for your DC motor interface with 1768 LPC 1768. So we'll start with a program here. Hash include LPC17XX.h, as we know that it is a header file which includes all your 1768 series header lines. And second pin is like here we are going to declare keys. As you have seen in the previous experiment, the keys are used to control certain interfaces or applications. So here also same thing we are doing. What is that means? Keys are declared, as we know that hash so hash defined key pin LPC GPIO1 means, see here you can see that your all the keys are connected to the port 1. That's why we are declaring hash define key pin space with a LPC GPIO 1, which is connected with a FIO pin. Okay, you know FIO means what it is in the previous experiments also. FI means fast input output pins. Okay, so then as we know that in this experiment, few things you have to remember. If you keep, if four functionalities or different functionalities, basically to stop a motor, to increase the speed of a motor, to decrease the speed of a motor, clockwise direction, counterclockwise direction. So almost 5 keys is been assigned for this. uh, hash define key stop, it is assigned for your P1.14. It's a port 1.14, and hash define key increment 1.15. Hash define is been decrement is being used for 1.16, and your hash define key clockwise direction, you want to rotate your DC motor, the key is used is 1.17, and the last one is hash define key counterclockwise direction or anti-clockwise direction, 1.18. Okay, so this is the basic things which you are going to declare with the hash defines. It's most of the experiment is being repeated. Okay, so keep in mind 5 key pins are very important: stop, increment, decrement, clockwise direction, anti-clockwise direction. So based on this only the DC motor action will be done. Next part is like subfunction is been written here. Void delay unsigned int count, unsigned int j is equal to 0, I is equal to 0. For j is equal to 0, j is lesser than count, j plus plus. For I is equal to 0, I is lesser than 12k, I plus plus. Because just I briefing here, I'll come to once again to the delay how it works based on your programming. I hope you have understood hash define. It's very important, and a subdivision of a subfunction of a void delay. So coming to the next one here, as we know that all the programs we have to initiate the system files. So that's why void system init void. This is a basic repetition of your stuff in all the programs, and your main program starts here. Here two things we are going to declare like variables. You init 8 count is equal to 0, match is equal to 5. So here the two variables are count 0, match 5. I'll let you know what is this count 0 means, match 5 means. So it is unsigned integer 8 bit. That's why it is been UNIT 8 underscore 3. Okay. This is here. This is a red mark. It's like complement. Then we'll go for the main program here. LPC GPIO 4 FIO DIR or 0x3000. As I told, uh, what is the importance of 30000 in the previous slides? Okay, it's very important. As we know, FIO DIR means fast input output direction flag of port 4. You are sending a data with a 3000. It's nothing but in the complement also we have put up to set the direction of P of 4.28 and 4.29 as an output, because these two pins are connected with your LPC L293D, which are in turn connected with a DC motor. That's why we are declaring this first point. The next one is LPC GPIO 2. Okay, FIO DIR or it's a 8. Why? Because like to set a 2.8 as a output. Okay, then LPC GPIO 2 FIO clear or with a 1 point so 2.8. Why? Because like to send a low on the particular pin. So that's why first initially we have to send a low onto this particular. That's why we are sending a FIO clear. Okay, so these three steps are very important, like direction flag or direction register, which makes you the configuration of other ports. Okay, the next point is like as I told, these whole operation is controlled with the keys, so that's why that also we have to configure that is a next 2 points. It says that LPC GPIO1 FIO DIR and with not of key stop, key increment, key decrement, key clockwise direction, key counterclockwise direction, because like any one of the thing it has to be activated. That's why you are going to do it. And as we know that FIO DIR is a direction register, because like that is the input, because these keys are input, that's why we are going to do this one. And LPC GPIO FIO set, because we have to make it this as a set, because as I told, it should be act like a input. So I hope this slide you have understood. So we'll jump to the next slide. While of one, as we know, while of one is a continuous process, we are going to do it, so that's why while of one has to be declared. Then next, what is the operation we have to do? We have a different operations which we have declared previously. So here what happens, like if key pin and a key stop, because here you are going to do certain action practically. If key stop key is being pressed and it is compared, or like and with the key pin, whatever you key pin is being pressed is compared with a key stop. So then what happens, it has to jump to this line. If like LPC GPIO4 FIO pin with a 3000, then LPC GPIO2 FIO pin is equal to 0x000010. Why? Because like stop means you are not going to do any operation with DC motor, so that's why these commands has to be sent to the particular L293D. So that's why we are sending this one. If key stop is being pressed, okay. And you have to keep in mind, whatever the key are pressed, the key value will be always stored in key pin, and that is compared with respect to the operation. Okay, the second thing is that if the key pin and with the key clockwise direction, okay, is being pressed, what you are going to do, LPC GPIO4 FIO pin 0x2000. As I told you, this is a bit pattern for clockwise direction. So 200 is been sent. Then you are going to enable. See, keep in mind that enable pin every time we have to activate. That's why in all of the sub functions, the key pin enable pin will be high. The next part is like if key pin and with a key anti-clockwise direction or counterclockwise direction, what you are going to do, LPC GPIO4 FIO pin 0x1000. So this is the pattern. You make the DC motor to run in a counterclockwise direction. That's why you are going to enable once again. And the same wise, like you want to increase the speed of your DC motor or decrease the DC motor. So this is the one phase which we have done, like stop the motor, clockwise direction, anti-clockwise direction. Based on this, one more operation we are going to do, that you can increase the speed of a DC motor or decrease the speed of a DC motor. And in our program we are not using pulse width modulation. Basically the working principle, if you see the controlling part, if you see the DC motor can be controlled with the concept of pulse width modulation, but we are not using here pulse width modulation. Just we are using a some of the increment and decrement operation to increase the speed and decrease. So let's see how this program will works, or a sub function. If the increment key is being pressed, okay, keep in mind, if the increment key is being pressed, okay, if it match is lesser than 100, means this is a maximum value we have given match. You know, in the program here we have declared match as a 5. It can be vary, but this is the feasible values which we can view properly output in your board. So that's why if you see here 100 is greater than 5, yes, it is 100 than it's greater than 5. So match plus is equal to 1, okay, while keep in and keep in is been increased, means it will be pressed, okay. Same wise, how many times it will be doing, keep on like 100 times, okay. So 100 times means like 100 minus 5, whatever it is there, Okay, that much times it will be keep on incrementing. Same wise, you want to decrease the speed of your DC motor, what you are going to do, keep in and with keep in decrement. So if match is greater than or equal to 10, so here match is 5 is greater than 10, so what you are going to do, match minus is equal to 1. So once again, while you are testing that whether like a decrement key is being pressed or not, so this it keep on doing until unless it reaches to minus 5. Like 5. Okay, so this is the functions of your increment and decrement. The next part is delay of 10. So after performing this operation, you are going to have a delay of 10. So we'll jump to the delay program. Here just delay is a sub function you are calling here, and 10 is a parameter you are going to pass it. So it comes here to the delay program. So unsigned int count, so in the place of count it is equal to 10, which you have passed the parameter. Unsigned int j is equal to 0, I is equal to 0, loop within a loop. That is a concept as you have studied in the lower semester. So for j is equal to 0, yes, yeah, j is equal to 0, initial value j is lesser than count. Here count value is what, 10. So yeah, 10 is greater than 0, yes. Then what it will do, it will jump to the next line. For I is equal to 0, I is lesser than 12k. Yeah, it's keep on incrementing this value, I value up to what, 12k. And once again it will j plus plus, then it will compare. J plus plus means 1 is lesser than 10, yes. So what happens here, 10 into 12k times this delay will be executed. So the examiner may ask you to change this value based on the speed of a DC motor. So it will come back to the once again count plus plus. Okay, so count here initially we have declared as a 0, so it will be incremented by 1 time. If count is greater than is equal to match, yes, so means here what we are doing, 5 is a match, okay, and that is a initiated and we have executed here match how many times, then it is like how many times you are going to execute. So like that's why if count is greater than match, yes, LPC GPIO 2 FIO clear. Okay, means it is greater than match means you are going to clear your 2.8. You know 2.8 is a enable pin, else it should be set. So if count is greater than 10, count is equal to 0. So this ends the DC motor program. I hope you understood the program, and try to download this program or type your program into the kill software and dump the program and check the possibility of your DC motor operation. So keep in mind that these values as we have tried in the lab, that's why we have kept it. So it may vary in your case of external lab session. Thank you very much from myself, Pawan, and Chaya, Prabha, and Anjanath Chari.